Here in this video, we would like to talk about expansion of gases. The first thing that I want to tell you is when compared with the solids, liquids expands more because the molecular force is less among the molecules of the liquid. Even when compared with liquids, gases expands much more because the molecular force between the molecules of the gas is almost non-existent. To measure the expansion of these solids, we have coefficient of linear expansion, coefficient of areal expansion, and coefficient of volume expansion, which says that a solid could expand along its length, area, and volume. When you come to the liquids, there is no linear and areal expansion because liquids have no fixed length and shape, but they have only volume expansion. But as the liquid is taken in a container, depending on how the container behaves, liquid can have one kind of volume expansion called apparent expansion, or it is really slightly different, that's called real expansion. Thus, liquids have two kinds of expansion coefficients. When you come to the gases, obviously there is no length and area like liquids because gases also have no specific length and area. They occupy all the volume. So they have only volume expansion. But when you come and talk about liquids, there is another significant parameter that has to be taken into account, that is pressure. In the case of solids, pressure is not going to affect that much seriously the expansion, or liquids also pressure is not going to play an important role in understanding expansion. Pressure has no significant role. But when you come to the gases, pressure cannot be ignored because pressure impacts volume in such a way that we have a huge law called Boyle's law, which says that pressure is inversely proportional to volume, of course at a constant temperature. Or we have an ideal gas equation PV equal to nRT, which tells you there is a relation between pressure and volume. So pressure cannot be ignored. Pressure has a significant impact while we are studying the expansion of gases. So when we are talking about gases, thus in the case of gases, while you want to study the expansion of gases, we have three parameters into consideration: pressure, volume, and temperature. And we cannot study these three parallelly, simultaneously, because when you vary pressure, temperature varies. When you vary volume, also temperature varies. Due to whom the other is varying is very difficult. Due to which how much the other is varying, identifying it is very difficult. So what do we do to understand these three parameters? It is difficult to study these three parameters simultaneously, we keep one parameter constant while we are studying the expansion and work with other two. You understand what I mean? You define it in two ways, like this. First, when pressure is kept constant, change in the volume of the gas Vt minus V0 is directly proportional to original volume and also directly proportional to difference between temperatures. Thus, we can eliminate the proportionality by putting a constant alpha, and that alpha can be written like as Vt minus V0 by V0 into delta T RT, and of course this is all happened at a constant pressure, and we call this alpha as coefficient of volume expansion of gas at constant pressure. So that's when you keep the pressure constant. But there is other possibility. What is the other possibility? As I said, in the three parameters, we keep one parameter constant. So out of pressure, volume and temperature. Now, let's keep volume constant and study how the pressure gets affected with respect to temperature. And we can say change in the pressure is directly proportional to initial pressure, directly proportional to temperature difference. We can combine both of them as delta T. We can eliminate the proportionality with a constant beta. So beta can be written like change in the pressure by original pressure of the gas at 0 degree centigrade per 1 degree centigrade rise in temperature. And we call this beta as pressure expansion coefficient of gas at constant volume. So, as you understand by this time now, gas has two kinds of expansion coefficients. What are the two kinds of expansion coefficients? Are a volume expansion coefficient of gas at constant pressure, and the other one is pressure expansion coefficient of gas at constant volume. How do they are related to each other? We will derive it in the other video, next video. But for now, I want to tell you that while we are studying the gases, we cannot ignore the impact of pressure like we have done while we are studying expansion of solids and liquids, because solids and liquids have no big impact of pressure on their expansion, but gas do have. Thus, gas has two kinds of expansion coefficients: volume expansion coefficient of gas at constant pressure and pressure expansion coefficient of a gas at constant volume. We will find the relation between them in the next video. Thank you for watching.